All right, so this is homework 5 for CDA 3103, and this is question 1. What it asks us to do is it wants us to find the decimal value of this number a, and then it wants us to show that decimal value in this form, right? That's sort of scientific notation, right? So we can do that, but how do we start, right? Well, we start by looking at the number and finding out the sign value. So I'll denote sign by s. We need to find the exponent of this thing, right? So I have our e here, and then we need to find our mantissa, which is going to need its own line. So I'll call it m, right? So this is what we need to find. We need to find the value of sine. We need to find the value of the exponent, the real exponent, eventually, and then we need to find the value of our mantissa, so we can all throw it into a function, or not a function, but a formula to find the decimal value in this sort of form, and I'll show you that formula in a bit. We just need these three numbers. How do we do that? Well, for sine, it's really easy, right? All I had to do is look at the most significant bit of this binary number here, right? So the most significant bit is the leftmost bit, which happens to be this one right here. So um, just by looking at it, right, my sine is going to be equal to, well, -1, right? If this is 1, then my sine of my actual number is negative. If this is 0, then sine is equal to 0. So that means that your sine's positive, right? So our sign really holds the value -1, right? We have a negative number here. For the exponent's stored in these 8 bits here, right? So we need to find what its value is in decimal, and then we have to do some subtraction on it because right now we have a biased exponent, right? It's biased by 127. We need to fix that and find the quote unquote real exponent. So let's go ahead and do that. Let's look at um, these couple of bits right here. So what do we have? We have 1, 2, 3, 1, 1, 2, 3, 1. So this is our biased exponent. Let's get a decimal value from this, right? So right here I have 2 to the 0, and this is 2 to the 1, 2 to the 2, 2 to the 3. Then I have 2 to the 4, right? So what is this value in decimal? It's simply equal to 2 to the 4 plus 2 to the 0, which is equal to 17. Right. So 17 would be uh would be our biased exponent. How do we get our real exponent? This is the exponent we actually want because this is the exponent that will be present in this sort of like y value here. Right. So how do we do it? Right. All you got to do is take your biased exponent and I guess subtract the bias. Right. And what do you get out of this? You get negative 110. Right. So we just found our sign. It's negative. We just found our real exponent. It's negative 110, which is really, really, really small, but it still works, right? We did all the processes right. So yeah, I guess our number is going to have a proper exponent of negative 110, right? Okay, so that's all fine and dandy, but we have to find the mantissa and then we have to find a decimal value for it, right? So how are we going to do that? We are just going to look at the rest of the bits, right? So we've already used all of these in our sort of calculations here. I'm really just dealing with this bit onwards, right? That's what I'm dealing with. I'm dealing with these numbers. So let me go copy that down. Let's see here. We got, what is that? 1, 2, 3, and then we got this, that, and then I'm just gonna. What I'll do is I'll just put down a 0 here. I'll put a 0 here, and like a little ellipses to just to note that the rest of these numbers are zeros. Okay, so now how do I get this sort of like binary number here into a decimal number? Because this is what we need. We need a decimal result at the end of the day, right? I'm going to look at it and I'm going to identify where I see ones and then convert those ones into decimal values. So here's how I'll do that, right? So I got 3 zeros, right? And then on the fourth bit, so to speak, right, I got a 1. So how am I gonna denote that? I'll do it like this. I'll say m is equal to 2 to the -4 because on the fourth bit we got a 1. That's why I didn't include -1, -2, -3, right? I found a 1 on the 4th bit, so that's why it's 2 to the negative 4. And now let me go search for other um, on bits or 1 bits, right? So this is 5, 6, 7, 8, right? So I'm just going to add that to our mantissa, to the negative 8. And these are both decimal numbers, right? So what does that total up to? If you grab a calculator, right, this is going to total up to 0.06640625, and this is for sure a decimal number, right? Because these two were decimal numbers, right? So this is our decimal representation of the mantissa, right? And we already found our exponent, our proper exponent, our real exponent, and we figured out that the final result is going to be negative. Now, how do I guess, uh, put this into a formula, right? Well, the formula is this, and I really should have called sine equal to 1. So you'll see why in a second, because if I had kept it as negative 1, it would have made the formula look a little stranger. But yeah, we're just going to call sine equal to 1 since this MSB was equal to 1. Okay, so here's the formula that we need to plug in. I got negative 1 raised to the s, right, times this constant 1 plus the mantissa in decimal, right, times 2 to the power of your actual exponent, right? So here's our sine value, right? Here's our exponent, we place it in here, and then here's our mantissa, we'll place it in this m, right? So literally all we have to do is just, just like fill in our values with what we know they are. So I have negative 1 raised to the 1 since sine took on the value 1, right? I got it's all multiplied by 1 plus the mantissa, right? What do we find the decimal mantissa to be? We found it to be this. So I'm just going to copy that over, right? Plus 0.06640625. And of course, that's times 2 raised to the exponent. That's not the value like 2.7 onwards. This is just this value right here. This is the exponent, right? So what did I find my real exponent to be? It's negative 110, right? So of course, just simplifying it a little bit, right? This is really equal to negative 1.06640625. Now it's going to be multiplied times 2 to the negative 110. This is a decimal value, right? And it's of the form that we wanted it to be. So this right here would be our final answer. All right, I hope that helped.